Hello, I'm Reggie York, and I'm doing a presentation on the use of the York Excel file when you have the AB single subject design and you've measured your one client's behavior in a manner that is dichotomous, that is to say, it was recorded as either yes or no each time that it was recorded. This is an illustration of how to use that file when you're using the binomial test to test your hypothesis in the situation of the AB single subject design with dichotomous data. There are many other applications of the binomial test. This is just one such application. The binomial test tells us the likelihood that chance explains the differences in the frequencies for two categories when these frequencies are compared to a threshold fraction. For example, if you have 10 favorable recordings in the treatment period and three that are not favorable, and you're comparing that to a fraction of data of favorable recordings in the baseline period to see if the treatment period had more favorable data than the baseline period. What you need to go forward with this lesson is the special York file, which is available for those who have the book by York. Data on a single client that is measured either as a yes or no. Data during both a baseline period and a treatment period. Here are a couple of examples. You record the number of times a client turns in a satisfactory homework assignment each week during the 20 weeks of the baseline period and during 20 weeks of the treatment period. This will be an example we'll use in this presentation where we will present some hypothetical data and analyze that data. Here is another example that would be appropriate for this application as well. Suppose you had a married couple you were working with counseling, and you measured the number of times this couple reported to have had a major fight each week during a 5-week baseline period and the 7 weeks during the treatment period. So for some reason you have the ability to collect data on both of those periods of time. In our particular case, we're going to illustrate, here is the hypothesis. The client will have fewer disciplinary actions during the treatment period than the baseline period. Data you'll need when you use the particular Excel file is the number of favorable recordings during the treatment period. We're talking now of the treatment period. So we have the number of favorable recordings during this period and the number of unfavorable recordings. Here we're talking about whether or not a person turned in a satisfactory homework assignment. What else you'll need? You'll need to have the proportion of favorable baseline recordings as indicated by a fraction. So we've just looked at what you need in regard to the treatment period. Now we're talking about what you need in regard to the baseline period to insert into the Excel file to determine whether statistical significance was achieved. Here's how you can calculate the proportion of favorable recordings. Use this example. If 8 of 20 baseline recordings were favorable, you would have a percentage of 40% favorable, and this would be a fraction of 0.4. So 40% would be converted to a fraction of 0.4. So now we have a fraction of 0.4 for the baseline. This is the fraction of favorable recordings during that period of time, to which we will compare the number of favorable and unfavorable recordings that were collected during the treatment period. Here is an example we'll submit these data to the Excel file to determine whether they are statistically significant. You can see from here, if you look in the left one here was a satisfactory homework assignment turned in during this grading period. You have a line of data for yes. This is the line that shows how many times it was turned in. This is the line that shows how many times it was not turned in. So we have a yes and a no. During the baseline period, 6 out of 20 were favorable, that is a fraction of 30%. It's a proportion of 30%, which would be turned into a fraction of 0.3. We had, during the treatment period, 12 favorable recordings, meaning they did turn in the assignment adequately, and 8 weeks during which the assignment was not turned in. So if you look at this initially to see whether or not the treatment period was better, you would compare the 60% over here with the 30% over here, right? That's a critical thing to examine when you lay out your data like this. Now we're going to talk about testing the hypothesis. Did the data go in the hypothesized or expected direction? Is one question that must be answered. We just noticed quite a while ago, by the way, that the proportion of favorable recordings in the treatment period was better than the same for the baseline period. The second question, was the data statistically significant? That's how we will use the Excel file to determine whether that statistical significance was actually achieved. Let's go back again over the question of did the data go in the hypothesized direction? We saw it briefly a moment ago. Let's go back over that again. Was the proportion of favorable incidents better during the treatment period than the baseline period? That's our basic data analysis question. In our case, we expect to see a smaller proportion of disciplinary actions during the treatment period than the baseline. Our data showed that 30% of the recordings during periods being recorded had a negative outcome, while 60% of the baseline recordings were negative. So we have a better proportion of favorable recordings. Did our data show improvement? Was the proportion of unfavorable recruitment recordings in the treatment period better than the proportion of unfavorable recordings during the baseline period? Let's look at the data again. Here's the example. We have to look at the line for yes. During the treatment period, 30%. During the baseline period, 30%. During the treatment period, 60%. So we can see from that treatment period was better than baseline because yes is better. This means a satisfactory homework assignment was turned in during this particular period. So as we look at what data we have for using the Excel file, you have a baseline period, 30% of the weeks had a favorable recording, and this percent is the fraction indicated by 0.3. So that's one piece of information that you will need for the to turn into the Excel file. The treatment period, there were 12 favorable recordings and 8 unfavorable, for a total of 20 recordings. Actually, the numbers you'll put into the Excel file are 12, which was favorable, and 20, which was total. So we have 3 numbers we're going to put into the Excel file. We're going to put in 12 favorable, 20 total in the treatment period, and a fraction of 0.3 for the baseline. Our data analysis question is the proportion of favorable recordings of behaviors during the treatment period better than the proportion of favorable recordings during the baseline period at a level that is statistically significant, meaning not easily explained by chance. Now let's look at the Excel file and put in these numbers. Here we can see the number. If you'd like to read these directions, you're supposed to be explaining it. If you'd like, you can hit the pause button here and look at these instructions up here. I'm just going to go ahead and show you how to use it. So here we see that the number of favorable recordings in the treatment period was 12. The total number of recordings during the treatment period was 20. The proportion of baseline recordings that were favorable is 0.3. which means 30% of the baseline recordings were favorable. So is this combination 12 out of 20 significantly better than a fraction of 0.3? That's the data analysis question. We get the answer right here, where we have the p-value of 0.00386. 0.00386, of course, is less than 0.05. So if you're using the normal standard in the social sciences of p less than 0.05 as data that is statistically significant, then you have data that has shown that to be true here. So, review quickly. Was our hypothesis supported by the data? First of all, was the data in the hypothesized direction? Do you recall? The answer there is yes. Was statistical significance achieved? The answer there is also yes, because the p-value was less than 0.05. I hope you understand this and it helps you in the future. Good luck.